This is question number 24 from the June 2014 Algebra 1 region. The diagrams below represent the first three terms of a sequence. Then we have term 1, term 2, and term 3. Assuming the pattern continues, which formula determines a sub n, the number of shaded squares in the nth term? So we need to try out these equations that were given in choice 1, choice 2, choice 3, and choice 4, and see which one correctly models the amount of gray shaded boxes that we have in each term. Let's start with choice 1. So choice 1 says a sub n is equal to 4n plus 12. A sub n is the amount of gray boxes that we know. It says a sub n is the number of shaded squares in the nth term, and n represents the term. So for term 1, n would be 1. For term 2, n is 2. So let's see, we know that for term 1, when n is equal to 1, for term 1, we want that a sub n should be equal to the number of gray boxes that we have in term 1, and that is 12. So when we solve our equation, when we solve a sub n is equal to 4n plus 12 at n is equal to 1 and at a sub n is equal to 12, we want this equation to be true. So for a sub n, we're plugging in 12. Is 12 equal to 4 times n, which is 1, plus 12? Is 12 equal to 4 plus 12? Obviously not. 12 is not equal to 16. So choice 1 cannot be the correct answer. Let's move on to choice 2. Choice 2 says a sub n is equal to 4n plus 8. And again, n is equal to, we're solving this at n is equal to 1. A sub n is equal to 12, and we want to see, does this equation make sense? Does it hold true? So a sub n is 12. Is 12 equal to 4 times 1 plus 8? Is 12 equal to 4 plus 8? 4 plus 8 is 12, and 12 is equal to 12. So far, this equation holds true. We have to try this for term 2 and for term 3 as well. So we're going to use the same equation, but now we're going to plug in n is equal to 2, and a sub n is equal to 16. There are 16 shaded boxes in term 2. We want to see, does this equation still make sense? So a sub n is 16. Is 16 equal to 4 times 2 plus 8? Is 16 equal to 2 times 4 is 8? Is 16 equal to 8 plus 8? Yes, it is. 16 is equal to 16. So this equation holds true when n is equal to 2. So for the second term, it is also true. Now we have to try it for the third term. So we're solving at n is equal to 3. And a sub n is, we have to count the number of gray boxes in the third term. And that is 20. So a sub n is equal to 20. And let's rewrite the equation that we have for choice 2. For choice 2, a sub n is equal to 4n plus 8. So for a sub n, we're plugging in 20. Is 20 equal to 4 times 3 plus 8? Is 20 equal to 4 times 3 is 12 plus 8? 20 is equal to 20. So this equation in choice 2 holds true for term 3 also. Therefore, it holds true for all three terms, and choice 2 is the correct answer to the question. You could, if you want, try out choices 3 and 4, but it's not necessary because, like choice 1, they will not be true.